Welcome to Kenton's videos. Enjoy the video.
You begin by confirming essential prerequisites, data structures, and complexity. First, read the prompt until you can state the input and required output in one sentence. Then, scan constraints like N, memory, and time limits to guide approach selection. Once done, map which structures or patterns fit, hash, 2 pointers, sliding window, divide and conquer, and pick one to prototype. Make sure to note edge cases as you list assumptions. They shape your first implementation choices. Now you design a concrete plan. Write a short pseudocode, highlight invariants, and explain why it terminates. Next, pick the technique that matches constraints. Use dynamic programming for overlapping subproblems, greedy when a local optimum leads to global. Once chosen, annotate where complexity comes from and identify expensive operations to optimize. Then, craft test cases, trivial, typical, worst case, and boundary values. Make sure to rehearse a mental dry run on one test before coding. You code in small steps. Scaffold function signature, implement core loop or recursion, then add edge case handling and micro-optimizations. Once implemented, run your prepared tests and include a stress test against a brute force solution when feasible. If a test fails, reproduce the smallest failing input and add assertions to narrow the fault. Finally, refactor for clarity and reevaluate complexity. If things still break, one key troubleshooting tip: isolate the failing component and compare intermediate states against a correct, simpler model.
Thanks for watching. Consider subscribing if we helped you.